Okay, I heard one person say respond, but that's fine. We're almost close to the weekend, so I hope we get through this session, and then you can have a good weekend. So today, I wanted to start with a couple of quick logistical topics. First is um, okay. Let me. So the first thing is about groups. I know last time some of you had not yet formed groups. Teng Teng has sent a couple of reminder emails to everyone. So I think some of you have already formed groups. For that, this is not important. But for folks who have not yet formed groups, I strongly suggest um, forming groups. Look at the list of participants, private message them, or you can contact me and Teng Teng, the TA, and we'll try to match you up. I know last time there was Blake. Did you find somebody? He's muted, but okay. So for example, Blake was looking for a teammate last time. So basically coordinate with me and Teng Teng if you haven't yet formed a group. The group formation is not super critical, as in like there's no deadline today or tomorrow, but at the same time, it'll be useful if you coordinate with each other so that you can zero in on a project idea and so on early on, and hopefully in the next four-ish weeks you can execute on it in a proper way. So I think some sort of planning or management is needed to execute a successful project. So that's why we are urging you to form groups ASAP. Second quick announcement related to groups and therefore about projects is that, let me share my screen actually. Um, project is that it's good to have a look at the syllabus topics. So you're not restricted to, so there are a bunch of wide variety of topics being covered in this course. Some of the topics come later. For example, the first one, which is what we kind of spent a bit of time on, was about servers, web servers, and today also we'll do a little bit of that before moving on to serverless technologies. So there's web servers, there's serverless technologies, there is the use of Docker or container ideas from that set of techniques. There's also container orchestration, and then there's stuff related to model pipelines. So where you schedule data pre-processing and then data training and then prediction on a bunch of test users, dumping the predictions to database, some set of jobs. You break down your full analytics process into small jobs and running them according to a schedule, for example, every night, every week. And then there's also a big data component. So some of you might have done a full-fledged big data course. So here we want to use Python and Jupyter notebooks to interface with an underlying Spark cluster to process data as well as actually serve models. Okay, and that we do in towards the end, where we do a streaming version of this whole model serving pipeline. And so you can do streaming on PySpark. And so those are new, those are, yet another set of topics we'll cover. And finally, so many of the topics towards the end, if we have time, we'll try to cover them. But the last one is about online experimentation, which is about A/B testing. And A/B testing is such an ubiquitous thing today in both tech companies and companies whose main objective is not tech as in internet focused companies, but still they need to do experimentation, for example, on their marketing or, for example, their brand presence and things like that. Just to name a couple of directions. And so this A/B testing is a great tool as well. So I guess coming back to the project, I'm suggesting not be tied to, let's say, just model serving or serverless or Docker. There are new, other topics to be to also you can pick it up. And if you want to pick it up and you don't see material yet, then you can contact me. I can create a draft, a bunch of material, or point you to right resources if you want to pick up something else which come later. Okay, you don't have to wait till the last week to figure out about online experimentation or A/B testing and then start working on a project on that. Um, okay, and second quick logistical announcement was about, let's see, is it here? Yeah, so I have a, so I mean, so I've just opened this on NB Viewer. As I said, you can get to the notebooks directly from GitHub. You can click on any of the notebooks. GitHub will typically render it, or you can use nbviewer.jupyter.org to open the same repository and look at the notebooks. Okay. So what I did is add an extra notebook file. It's just a temporary, think of it as a Scratch file, basically. And it has like a link to a Zoom recording, which I did for folks using Windows who at least one way to access a remote server. In this case, we are talking about the Amazon EC2 instance. So there's a link to the Zoom recording. Have a look at it if you're still unable to get yourself set up on your machine. On your machine, you don't have to do much, except for install, for example, one piece of software called Sigwin. You can actually get away with not doing that, but if you know some other ways, certainly pursue them. But if you're stuck, this is one way to be unstuck on this point and move forward with web servers and serverless and all that stuff. Okay, so that's a quick second point. And the last point is about the motivation of this course. Now we are in the third week, right? And you may be wondering, hey, we haven't, we looked at one model and it was not even clear what the model was, right? I mean, last time we saw a Pytorch model, but it had a lot of I guess statements in that description of the training script. So this course is not about models, just to reiterate. It's about just getting exposure to technologies which surround model making, or basically model training or model diagnostics that you generally do in other courses, for example, 572. And so this article, blog post by somebody, kind of shows this point that you don't need just model building skills. It would really be helpful if you learn things which are in particular. This article is talking about in general what is called data engineering. Nobody has a really good idea of what data engineering means and what a data scientist, what's the roles of data scientists are, what the specific tasks are. Like, for example, I think here somewhere this person, it's a long article, but yeah, so you can see what are data practitioners responsible for. It says, hey, if you're a data scientist, maybe you want to use, like skills in 572 or somewhere else to process data, but typically this is going to be offline. You'll somehow fetch the data from a database, for example, and focus on building models. Okay, and of course model diagnostics, where, hey, why is the model's AUC 0.72 and not 0.76, for example? You want to kind of really drill down into that direction. Whereas these other roles, and also these, this data scientist role, it's not like they work in isolation, right? They will talk to these other roles, and these other roles include data engineers, ML scientists. They all have overlapping responsibilities. But data engineers are, I would say, a little bit of a hybrid between traditional software engineers and but who also know data specific or data science specific software tools and techniques. Okay, so and this is where, for example, some of the techniques that we see in this course are things that, for example, a data engineer would know, but it's good for data scientists or business analysts or people who build models should also know. Okay, so I strongly encourage you to look at this this article, just as a general read. You can see, for example, this person has analyzed some for example, the frequency of role that companies are hiring for, and you can see that there's a big percentage on data engineer, and then there are like trailing ones, which, for example, last one is deep learning researcher, and many of the researchers are towards the tail, whereas engineers which just means that you should be able to plug in different systems and get data flowing, predictions flowing, and so on. They seem to have a higher number of roles. Okay, but anyway, this is something I just wanted to quickly mention. Any questions up to this point about logistics, group formation projects?
Professor, I have a quick question. Now, I know we are already in week 3 into this learning process.
Mm-hmm.
Now, do you have any recommendations or suggestions on how soon should we reach out to you or
Mm-hmm.
the TA for starting on something? So that
For your
we have to
project,
prepare
I would
what
say
and everything.
earlier the better.
Yeah,
Sorry,
right. We have like only the month of February, I see, because March
yes,
something you put as the timeline
yes,
for final submission.
yes, 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 yes. That's exactly why we are urging you to form groups, because that's the minimum, that's necessary but not sufficient to excel in the project. But yeah, I mean, you should reach out to, I mean, not you, but everybody, by the way. You all should reach out, talk to your group mates first, first of all. I would say estimate about 4 hours or 5 hours to get to a conclusion that both of you are happy with in terms of some technology that you want to explore. And that's where I was saying that, hey, there are so many other technologies that also are there, are part of the, sorry, I think, yeah, there are many other things that are part of the course, and you can pick them up, and if you don't know anything about them, you should know something about them. I mean, you can Google or in some way know that, hey, Spark, I think some of you who have done big data know what Spark is about. So converge to a rough idea of what you want to explore. Okay, so the project is about here. This course's projects are about, and it also is listed in the project. Sorry, where is the project page? Like what's the aim? So it's basically about exploration. But at the same time, you should not everybody should be just exploring, hey, let me spin up a EC2 virtual machine and just run something on instead of Flask, maybe use Django. But for example, that could be an addition. But just using Flask on EC2, we are already seeing in class. So to avoid some simpler project scopes, or to avoid very ambitious project scopes which cannot be done in 4 weeks, it's good to brainstorm with your teammate and just let us know, and we'll certainly let you know if it's too complicated, or if it's if you can do something more. Uh, and uh, and that's why, since there are no assignments, I would definitely ask folks to have a budget, a time budget. See, every project, if they're, let's say, 4 weeks now, to the last week, fifth week, right? So in 4 weeks, you can imagine, let's say, on average, 3 to 4 hours. So that would roughly be a sense of like a median project involvement timeline. But that's just about, hey, spending the time on actionable items once you have a plan in place. And so you want to get to a plan ASAP, like in the first 3 hours or first 5 hours of this budget of time. I hope that helps. All I'm saying is, yeah, definitely contact us ASAP, by the way.
Yeah, hi, this is George. I have a quick question. Is there anybody that is not in a group other than me? I'm just
Good question.
checking.
Yeah. So Blake, are you in a group? I know you emailed me earlier.
Yeah, I found a partner.
Okay. So anybody else? Okay, I think I can cross-check afterwards. I don't have the link to the Excel sheet myself. I think everybody has access to the sheet, right? You can see somebody
Yeah,
can
I
match up.
saw.
Yeah.
I was just checking who didn't have a group. So
Okay.
some reason,
Yeah.
I think.
Yeah, I see 11 participants. So I mean, excluding me. So there should probably be one odd one out.
That's me.
Okay. So no issues. I mean, so there are two options. One is if you want to join an existing group, or you can do a solo. And appropriately scope it down so that
Okay.
So what estimate I earlier said about 20 hours, let's say, is per person, right? So that's 40 hours of project work.
Okay.
Yeah.
I mean, let me know if somebody is willing to accommodate me. Otherwise, I'll do it alone.
Yeah, take this as a fun project, right? I mean, this is an elective course. You took it to just learn about something, some new technology. try to not stress about grade and focus more on trying to learn something new. So I would suggest pick a model that you've already, you already know, or pick a very simple model and explore the technology a little bit more. Okay. Yeah. Okay, so with that, let's me get back to where we were last time. So let me close projects. And
Professor, that FAQ, whatever you mentioned, that it's not opening up through GitHub, not the end viewer, through this. I'm trying to just check out the file. It's not loading it up.
okay. Git has its own issues. I just opened it, but okay. So that's what GitHub's rendering. Sometimes may not work. So I would suggest go to this NB viewer site. So it's just this. This is the link, and just open whichever URL. As long as it's a notebook URL, it'll just render it. Okay. I just opened it. By the way, it seems like it's just one cell which says link to the sun. So I was thinking I'll add more stuff if there is some ad hoc explanation or something that is needed. Okay. Okay, so I think this is not needed. Okay, so let me come back. So sorry, I think we are in module 1 for some time now. But what I did is I removed one of the models from recommendation models because I think looking at 2 different models, I think is just too complicated. So in the recommendation models notebook, which is 5th section of the first chapter, I've only kept one model, which is the Pytorch model. Okay, and that's because it's very transparent of what the model definition is and everything. And I'll not explain the model right now, but that's essentially what's going on. I hope I deleted it. Yeah. Okay. So, and there's an inference piece as well, where once you have a trained model, it's dumped to file somewhere here, right? It's dumped to file, and it did work. Okay. So it's dumped to file, and the cell, I don't think I see the cell number, but the cell where it says recommendation inference is where we read that model here, loading that model, as well as load an extra metadata file, which has the movie ID to movie name mapping. And then it, and we can print for some sample users, and that's inference. Okay, so once you already have a prepared model, whatever. So what I mean by prepared model, the simplest prepared model is just a list of numbers. Okay, think of a linear model, right? So multiple regression. So if your input feature dimension is 10, then the number of parameters in your linear model would be, let's say, 11 with one extra v for the intercept. And so you'll just have 11 numbers. Okay, whether you represent that as a list of numbers, whether you represent that as a dictionary, or whatever, anything else is up to you. So that's the simplest model representation. So when I say dump a model after training, it's as good as saying, hey, these are the 11 numbers, let me save it in a file, and then maybe and when doing inference, I just read those numbers, and then if I'm doing linear regression, I just have to do a product, right? Product of element-wise, products, and then sum them up, and that's my predicted score. Let's say if I'm doing linear regression, so that could be as simple as that. Here, it's a little bit more complicated because we are relying on an underlying neural network library called Pytorch, and so that has its own way of loading those numbers, and that's where this model.load state dictionary is making the same thing, which is just loading those numbers. The numbers are not just 10 or 11 numbers like in the case of linear regression. It just happens to be a little bit more numbers. Okay. And once you have those numbers, it's just a question of you can just pass the same model, whichever model it is, into a helper function like get top 10 or top n recommendations, and it just calls the model. It just calls the model onto the inputs, appropriate inputs. Okay, feature vectors appropriately chosen. Okay, so that's what this notebook is. I just removed. Oh, I did not remove it. I thought I removed it. Is this okay? Let me go back here. One hour ago, recommendation models. Sorry, I don't know why NB viewer is not showing the latest. Yeah, I just removed. So as you can see, sorry about that. let me go back to here. Yeah, so it's the same thing. All I was saying is that in this section, I only retain the Pytorch module. And that also seems quite complicated, right? There seems to be several lines and several helper functions. And for those who are new to Python, I would just keep it at the highest level, in the sense that you don't need to know the details of the helper function, what's happening inside, but at least you should know what's happening at the highest level function. In this case, the main function, okay, for the inference part. Same thing on the other side, which is the inference. Which is the training side. You just need to know what's happening at the training level, okay. And those folks who have tried scikit-learn or even some of the R packages to train, you will see, hey, load the data, get some hyperparameter choices, and then instantiate a model. And then in Pytorch's case, you also do extra stuff, which is instantiate something called an optimizer, and also instantiate a way to get batches of data rather than training on the whole data. But that's it. And once you do that, it's a for loop where you keep updating the model weight. So it's basically just doing gradient descent at this point, but you don't need to know these details. And so many of the times you will not see these details. If you use, for example, scikit-learn, you'll just call model.fit, and that may or may not do gradient descent inside, but it's basically just this part, okay. And then once you have a fit model, you can just dump it. There are many other things that you would like to do at this point, which is get validation scores and plot, do a lot of model diagnostics, but this script is not doing that, okay. So any questions about models, anything about this part? All I did was simplify and drop the extra another model that we had, just to keep things simple. Okay, if not, let me jump back to where we were last time. So last time we were talking about Flask apps. Okay, so and before that, have the structure like this. So there's a question about, is it necessary to have the model function structure like this? No, actually, you just need to have all this in. You can have it in one Python file. By the way, or main function. No, this is not needed. So all this is, so this main is just, okay. So our emphasis is going to be on model serving. So model training file, whether you have a main file or not, whether, like you can drop this and just have this intended, you can just run this, you can drop this actually, and you can also drop this part. And if you're using a Jupyter notebook, you don't need those anyway. You can just execute each of the cells and it'll train. Okay. So there's nothing, about main. So this, I guess, just came from, I have a helper, so the scripts were originally written in Py files. And so I just copied the main function, but you don't need to. And this actually helps in not having too many variables in the global scope. So that's one reason. Like, for example, if you use some IDEs, you will be able to see which are the variables. Like in RStudio, you would be able to see a lot of variable names, right? And so this functions just hide those. Okay, so yeah, you don't need main here. Good question. So next, let me recap. A part of last time after in the office hour, somebody was mentioning about some uncertainty about web servers and what are. Oops, see, this is okay. I'll have to really rely on NB viewer here. Let me go to chapter 1. Okay, this is not even showing updated data. Okay. Okay, actually, let me do a different thing. Okay, I think this is not loading. So since we have so many different ways to see the same information, so let me just switch over to an IDE. Don't worry about this IDE. It's just a way to, this is a way to, this is again a Jupyter notebook itself. Okay, so there's nothing is different here. It's the same file. So what just cautioning that, hey, don't worry about this. If you want to try out VS Code and VS Code's Python extension, then this is the way you can open Jupyter notebooks in VS Code itself. Okay. Okay. So last time I was talking about I think we showed a simple Flask application. And what I kind of skipped over is that you know, how do we actually make a query and make the model predict something, and how do we get it back? Okay, and generally the way it works, and that's the way most of the internet works, is via via HTTP request. Okay, so which is a there's a lot of things underneath in how the internet works, but at the simplest form, basically for anything, okay, whether it's model predictions or whether to get an answer from somebody else, which is basically in this case a server, you basically make what are called requests. Okay, so the key idea is that you as a you are a requester, you are a client, let's say some third party. They will send some information to the server. Okay, so the server, just think of a server as again a computer. A client could also be residing on a computer, a different computer, like for example my local computer, your local computer, they're all clients. And then we send some information to the server through the browser or otherwise. Okay, and how do we send it? Because we know its unique IP address or some domain name, for example, right? So that's how we know we know the address of where this person is located who can answer our questions. And so since we know the IP address or something like that, we send some information, and then the server has a way to get that, is always listening and gets that information from, it is able to know, hey, this client sitting in, with IP address something in Chicago has asked for some information. Okay, and the server can process that information and send back a response. Okay, wherever the client is. And since the server knows from where the request came, it can send it back to the same direction. Okay, and the client is, once it makes a request, it's waiting on a response, and once it gets back the response, it can display it to the end user, for example, or do something else. And so there are many ways there are many different types of requests. And one of the types that we'll see shortly, and we saw last time very quickly, was a request type called the GET request. Okay, a GET request is generally used. So by the way, I'm being quite informal here because this is not a course on HTTP technologies and so on. So GET requests are mostly, just think of it as they're being used to access a read-only type of information. So hey, get me like the state capital of Illinois, or get me the state capital of Washington State. It's just, you just read from some location, maybe, server just has to read from some location and respond back. Okay, that's the type of request. So that's one type of request. Second type of request is where the client can give some information, send some information, but that information can be also modify some local information that the server is storing. For example, when I'm registering on a website, I send some information like my first name, last name, my email address, and so on. And the server has, server typically will store, let's say, this information. So this would be generally, a post type of request. And the others, put and delete, and maybe there are many more, but for us, get and post are pretty much enough. And here's an example, right? So you can see here, here's an example of doing a request. Okay, so here you can pick any website. So I just picked on my own domain here, website. It doesn't have a website. It can also be a IP address. Okay, so in Python, it's a very simple programmatic way to do this, and this is actually very useful. And you'll see a lot of technologies, for example, scraping technologies, also have beneath the scraping package, whatever it is, let's say Scrappy or whatever, Beautiful Soup. Underneath, they'll have basically a way to do this. Okay, and so request is the most I guess the simplest or the more lower lying package. So import request just like any other package, and then you can say request.get. Okay, so it clearly says get. It's a get request, and if I get it from there, then it's stored in a response object. Okay, so some object is created, and that response object will have a lot of fields. Okay, so let me actually execute this. And you can see it executed and it ran, it gave me some information. But if I hover over here, okay, if I do rest dot, let's say, and okay, it's not showing. Okay, maybe I should print type or something. Let me actually, not type, sorry. So you can see there are so many things within this object. Okay, so many of them are internal. You don't have to access them. You generally don't access them. But there are things that you can see that the response object got, like for example, content, cookies, something like elapsed. Headers is going to be important. Generally JSON, links, reason, request, status code, which is important. And status code is what is printed here. So you can see it says, when I print the object itself, it'll print, it'll have a default representation for it. So it's just printing its status code, which is response 200. Okay. And then you can access this object, you can access a field in it. For example, you can access the text field in it. Since this is just a web page, if you access the text field in it, it's just printing the text portion. Okay. And I'm only printing the first 300 characters, and you can see it's just some HTML stuff. Okay. So this is the simplest demonstration of how a request can be made. And so get request can be made. I think we'll defer post request to a little bit later. And here are some examples. So basically, so what is the status code? Okay, a status code of 200 means that the server was able to do its job and is able to respond back hopefully correctly. Okay, so it thinks it has responded correctly. Now, if you see a 400 code, it means that there's an issue with the client side. Okay, so you may not be even connected to the internet or something like that. If you see a 500 code error, so, and this is something that you'll commonly see with Flask, okay, and that's why I wanted to just quickly introduce this. You'll see that this means that there's an issue on the server side, okay, and with Flask, when you, let's say, run, Python flask.py or something, flask app.py, and you send a request, sometimes you'll see internal server error on the browser, which means that on the server side, the server failed in processing, okay. In the debug mode, you'll probably have to spend some time on debugging these types of errors, okay, 500 level errors. And you don't have to, so the Python, so we saw just one way, which is through Python to maybe make a get request, and the post request is very similar. It'll have extra stuff because you need to post some information, relevant information. Get, you are actually, since, as I said, since it's read only, you don't even have to send any more information than saying, hey, get me the text on this website, for example, right? And there are other ways. The first one is using a command line utility called curl, which is quite popular. So curl, for example, I can run this. Let me run it here, exclamation. So if I run this, you can see I got a file called output.json. So you can see output.json got created here. And so you can also look at it, right? So that's a cat output.json. You can see this is a JSON object that, it turns out that this particular location, again, and making a get request, if you just make a request, it just sends back saying, hey, it just basically echoes back, what did you do? So it's saying, hey, you accessed it, you accessed my server using a curl app and some some information. So maybe this is my IP address probably, and so on. Okay, so curl is one way to do that, and you can do the same thing with I can also curl the same thing. Like, for example, a website, I can save the output as, let's say, head.html, and I will see the text. Okay, that's one other way. And finally, the last way is using a tool called Postman. Not just Postman, but there are many tools. One example tool is called Postman. Let's see. Yeah, so this is okay, so where is Postman? Okay, so this is it's an app. It's some vendor who helps helps developers do a lot of things with respect to working with APIs in general. And so if you create an account with them, there's some different tiers, free tier. So you can also make a post request. Like, for example, it says, hey, create a request. This is actually more useful for more professional folks to test whether their API works. For us, by the way, API just means application programming interface. So API works for us, a model serving is an API, right? So we need to know, hey, which URL to hit and what to send to the model. So there's some information. So for example, if my model only takes 10-dimensional vector input, I can't send, let's say, an image to it, right? Or 11-dimensional input, for example. So So here I can create a request, and it can say, hey, request, if you want to pass any extra information, you can. Otherwise, just send it as is. So like here, I can do http bin.org/get. I think that's what the name is. And https. So if I just send without extra information, clearly, so you can see the same response. So you can see the response that I showed earlier is this response. And this time it's saying, hey, you did not access it from curl, you accessed it from Postman. And if you do it from browser, it'll just say from, let's say, Chrome or something else. Okay. Any questions about this part? Just a quick discussion about requests. Okay.
Hi, Professor. This is Laura. I just had a question. Are you doing this on the virtual machine, or are you just doing this on like normal Python?
That's a great question. I'm just doing it locally. So actually, let me switch over to the virtual machine. Actually, good point. So let me do that. For that, I need to know. I keep forgetting the name of the. Okay, let me just do that. Let me go back to the browser. And I just keep forgetting what the link is. So where is it? So I just want to know how to. I forgot this command. Let me do it on the machine. So this machine is the machine I started last time. Okay, so which is basically the machine on AWS, right? So let's do that. So I have a specific command that I'm going to run, which is exactly the same way. I just replaced my username and IP address so that I can now, and I think last time I had run the Jupyter server inside a screen session, and I hope you guys followed how to do that, which means that the Jupyter server has been running from last week, actually. All I am doing now is just creating a tunnel so that I can log into. Okay. So I can open it locally on my browser. So let me do that. Okay, so I executed that command, this command, on a terminal. And for us, we just need to go to localhost instead of 8888, which is what I was using for local thing. This is, and if I recall, it's IDS 594 probably is the password, extra password. Okay, save it, it's fine. So this is the machine. Okay, so here I did have MLOps notebooks that I git cloned last time. So what I need to do is, let's say, open a terminal, and this is on that machine. So as you can also see that it's on the base environment, Conda environment. I can do Conda activate data sci. I don't remember the name. Okay, so Conda nlist. Sorry, I had an extra hiccup last time. I think it's data sci 38. Actually, this is not very critical at this point, but let me just do it. Okay, so I have this now. As I said, I had git cloned this. So let me go into MLOps, cd in that, and then you can see that, for example, chapter 3 is not there. The FAQ file is not there. I can just do git pull, okay, and it'll pull a lot of extra things. And now if I do ls, I did not save it. Oh, error, your local changes to the following files will be overwritten by merge. Okay, so if you have changed stuff, then you'll have to undo those changes. Like if I do a git status, you can see that there was something that was modified. So the way to undo this is git checkout thing dot, yeah, git status. So anyway, so git checkout just gets rid of the stuff that I changed locally. Okay. So by the way, this is just a copy of that, that notebook. So our Git repository, right? So what I just did was previously I had a file that I locally changed and that was not letting me pull the latest information. So that's why I just did git checkout dot, which just resets, says, hey, give me the version that as if I had cloned it from the repository. Now, if I just do git pull, I should get a lot of stuff. But anyway, let's clear that. And if I look at ls, you can see that now FAQ is there and chapter 3 is there. Okay, so that's it. So the folder is the same. I just did a git pull, and this time if I do it, it says, hey, it's up to date based on whatever was there on the git repository, which is the GitHub link. Okay, so now we have this. Now let's go back to home, go to MLOps notebooks and chapter 1. Wow, we're still, okay, last time it was still running, and that's the issue. Okay, so we were looking at requests, right? So if I click on this, so you can see like from the remote machine, I can execute the same thing, and hopefully if it has a request package, it should work. But Postman is something that I was just showing it on the browser, so it's just a app. You can also download a version of the app locally if you want, okay, on Windows and Mac. Now this is taking some time because request is not there. That's great. So we can do, actually let me do it in the terminal. Conda install requests. Yeah, good question. Sorry, I was doing it locally, and one of the yeah, it's a good point. So actually, the right workflow is to always, do that initial command, right? So this command here, and just work on that remote machine, because that's how anyway Linux, and so everything is, you don't have to even, worry about OS changes and all that stuff. So, okay, what is this trying to do? Wow, it's trying to update a few more things, but it's okay. New packages, is it installing requests? Yes. Okay, so let me just press yes. Okay, now kernel restart. And then, yeah, so you can see it's the same thing that has happened. Okay, so now I hope that was fine. Thanks for the correction there. So now let me close this notebook section. Okay, let me save it, it's fine. And now let me get back to Flask apps. Okay, so what I spent the previous few minutes, like 5 to 10 minutes, was about explaining there's a get type of request, there's a post type of request. It's about just a client sending some information to the server doing some processing and sending back some information, right? And the different ways to do, execute this within Python. You can use request package. Outside Python, if you only want to do something on the command line, you can use curl, for example, as a tool. Or if you want to use a more, I guess a more commercial or a professional tool for working with APIs or making requests and getting back responses, you can use something like Postman. Okay, but there are many tools like this. So these are just examples. So now let's get back to web, serving models. And last time I was trying to show how the weather reporting service could run. Unfortunately, I think weather.gov did not have I think their API has changed, or maybe they're not giving us any information anymore. So what I've done is from last time, I've just added a different example. So, okay, so but before that, the core idea with the Flask web framework or any web framework is to make it easy for you to, let's say, since we are in Python, it makes it easy for the model, let's say we call model.predict or model, or prediction function, okay, of some sort. Somehow relate that to when a client or a browser makes a request to the server. Okay, so there's a server within which the Python environment is there. In our case, a Conda environment, for example, and there's a Python script, which is the Flask, program running. Okay, Flask program is running, and the client sends some information to this to a URL, which is like the IP address, and say /product or something. Then that URL will be mapped to a function. Okay, that's the job of such a web framework. That's one of the jobs of such a web framework. There are many other things that web frameworks can do, and there are many other examples in the exercises section. There are other web frameworks that you can try. But so that's one of the core things. Okay, that's the core thing that you want to understand from this part, that you can map a URL to a function. So let's actually go to a different example anyway, because that's the example I just verified that it works. So here's a simple example. This is again a Flask app. So you can see it's nothing to do with prediction at the moment. So let's focus on what are the key ingredients here. So this is a little bit of a non-trivial Hello World app. Okay. In the sense that the Hello World app in Flask would be, you make a request and it says Hello World, right? We are not doing that. We're gonna use the stuff that we learned just 5 minutes ago, which is the request library, to query somebody else to get us something, and then we'll forward it back to the client. Okay, so we are basically doing it in 3 steps. First, the client asks for something. We are the Flask, we are running a Flask program on our server. The program is gonna make a request to a third party, get some information from there, and then send that information back to the client. So step 1, get information from the client. Step 2, make an external request, aggregate that information. Step 3, send that information send that appropriate information back to the client. Okay, so, and all this is accomplished in this less than 20-30 lines of code. In fact, you don't even need this much code, but basically you just need to import Flask and create a Flask object. Okay. And we're also using requests because, as I said, we want to make requests to a third party. In this case, it's going to be a food image service. Okay. So how are we going to, so this mapping between the URL to the function is just happening using a function decorator here. Okay. It's called a function decorator. For folks, since folks are at the beginning level of Python, I don't want to get into the details of why, this extra line, what is the magic? It's doing some magic, right? It's mapping a IP address to, if somebody hits that IP address, it's calling this function. Okay, this function is called food, but you can rename it to anything else if you want. And that's the magic that the Flask web framework is doing. But once let's say somebody goes to my IP address / okay, and then I call this function. Okay, and you can see the function is very simple. It's basically checking, hey, is there an extra, like information of, do they want a certain type of food? Okay, that's the message here. If they want a certain type of food, then I'll copy that into my food name. So this is so data is a dictionary, as you can see. It's a dictionary, a basic data type in Python. So I'm adding an extra key into that dictionary with the value being which food type. Okay, and then what I'm doing is again a request.get, and we just saw this earlier. So we're going to do request.get to this API, this URL, or this remote machine server with the appropriate food type. Okay, give me images for this food type. Okay, and it'll respond, and that response is going to be saved in this request object, REQ object. Okay, this object I'm just copying I'm just saving the JSON response into this response. I guess response key. So for response key, I'm just saying the JSON object. JSON object is just going to be a dictionary. Okay. And I'm just saying, hey, we succeeded in getting the image. If this guy actually responds and response code is 200 or whatever, and so everything is fine, we have succeeded in getting information, we're processing information. Now all that's left is to send that information back to the client. Okay, so that's why this is enveloped in a try except or try catch type of wrapper. Okay, but that's not very critical. You can drop these for now. And the second, I guess, step is this code is saying, hey, if you don't pass anything, if you just hit my server, if you don't specify food type, I'm just going to pick some random food type and just send it to you. Okay, and that, again, the random food type, I can hit this link and it'll give me a random food type. And you can see, let me copy this and open, I can just paste this here. And if I press enter, it's just giving me a response. Okay, this was the query to this web server, which is not mine. So this is by somebody else. And they are responding with a, hey, here's a location for an image. You can just use that image somewhere else. Okay. And that's it. And so once, and then the remaining lines, I'm just saying, hey, if we succeeded, we have gotten an image, let me put it in an image string. Okay, this is HTML. So you don't have to be experts or anything about HTML here. It's just, I'm just explaining that, hey, if you get an image link, let me put it in an image, what is called an image tag. Okay, and written a very small HTML script where, if there's an image tag, it will show that image. Okay, so that's this Flask app. And if I want to run this, let me, I mean, I can run it directly, but let me do it in a slightly different way. Clear this. I'm going to create a file. Actually, we can create a file directly from file new, not new notebook, but here I can do new text file. Okay, let me do it this way. New text file, Control V, and just change this to my app.py. So I just copy pasted from that cell to here. And you can see where is this? This is in the, this is in some, I think it's in chapter 1 folder. Yeah, it's my app.py here. So if I just run again, Python my app.py, okay, let's run it. Okay, so you can see that, you can't see much here. Okay, actually, let's see. Okay, actually, is it even running? I don't know if I had Flask here. So let me just install it. Okay, I installed Flask. I think there is something going on here. Which, okay, Python is whatever 3.8. Okay, let me add a print statement because I'm not able to, I'm not sure if it is actually running. Okay, now it's running. So actually it's running at port 500, okay? But the problem is this is running on port 500 of the remote machine. Okay, so to access that, we'll have to do that previous command that we were looking at, this command again, but this time we'll need to change this 888 to 500 and this one from 8889 to, let's say, 5000 or whatever, something else, okay? So let me do that actually in 1 second. Okay, so I just did that. So I just re-executed this with a different IP here, and this is 5000. Okay, and that's where the app is running. As you can see, this is running at 5000, but that machine can only be accessed through SSH. So we are gonna do localhost. What is the number I chose? Some random number. I just chose 9900. So you can see it just showed me a burger. But if I give and the way generally you put a, if you want to give arguments, then you can do message equal to, I don't know what type of food. I don't know if this works, but let's try. Nope. This did not work. So let's see what the error is actually. Oh, it's a key error. Let's see. So the key error is from, okay, there was no image. Okay, so this actually, I forgot to, so this code has a flaw. For example, if we don't give, okay, let's actually run it again. Maybe pasta is not an option, but burger. Okay, let's try pizza. Okay, so actually there are a few keywords. So there is some error check that's not happening on this. Okay, this is a fragile code as expected. Just a minimum viable, I guess, example. So, so just to summarize, just recap, what did I do? I just copied this cell. So let me, yeah, I just copied this example food image service into a separate file. That's called, I just called it my app. And the file was in the same directory. It was in chapter 1 directory, but that's fine. And then I just called Python myapp.py. Okay, and it said, okay, we are running it at this IP address. But since on the remote machine, when we set up the machine last time, we only said, hey, only port 22 is allowed, nothing else is allowed. We run the same query. Okay, nothing else is allowed. We had to do the tunneling. Okay, another option is to open the port, open 5000 port on AWS's website. Okay, so actually, let me do that. Click on Amazon. Okay, sorry. Let me do that. In the meantime, there's a question. If we run the same query, will it change the image? Yes, I mean, that's expected because that's the API here. So let me refresh. Okay, yeah, I at least got a different image. And if I refresh again, a different image. So this service that's behind the server. So all we did is wrap our server around another service, which is actually producing the images, or at least giving us links to the images, and we can show them. So yeah, so the underlying service is a part of, is an example service that somebody created just for demonstration. Let me log into Amazon. Okay. Sorry, that was not intended. Okay. So now, I mean, so this is something that we did last time. So let me go back to the dashboard. I'm not creating a new. Okay, let me just go to services and EC2 and instances that we've been running for about a week now. So if I click on this, and as I said last time, we can look at security, security groups, and you can see that it was only allowing, it's actually allowing port 80. So maybe we can just change our program to run on port 80. Okay, so that's great. So this is the program that was running, right? So let me first stop the program, Control C. It stopped, and I come back here. This app.run, you can give a port argument, which is 80. Let's see if it actually survives. So, okay, okay, port 80 is generally not allowed. Okay, let's actually go back to under this port 80. Run it as is, and just open the appropriate port, in this case 5000. So editing bound rules, add a rule, custom TCP. So TCP is just a name for the underlying something beneath the HTTP request stuff. So it's one layer below in the network stack, networking stack. So again, the same thing, everybody can read it. And that's it. So save rules. And so now I can go back to EC2 instances. And now I think anybody can access this. So let's see if it is the case. So let's click on this. Oh, no, not this, but colon 5000. Oh, it's not HTTPS, it's HTTP. Yeah, so actually you guys can also access this URL. So this is just, we just opened the port for everybody to access it. So this is literally this, what is this called? Python, yeah, Python myapp.py. And you can see some requests hitting, some requests, some hitting, and also the server saying favicon is not there, so it's 404 for that part. And I think a couple of people have tried to access maybe. Anyway, any questions about this part? So what we did was just copy the Flask script that was there in the cell and run it. Okay, I hope it was not too complicated. I think I made it a little bit complicated because of switching from one editor VS Code to here and all that. But anyway. Okay, let's move forward. Any questions about this part? Okay, if not, then I want to move forward to the model serving, and this is what we wanted to get to on the first lecture, but it's okay. So here, what I've done is exactly the same thing. I mean, it's exactly the Flask app, but I've imported a few extra things, and you can see what is the extra stuff. Torch, which is exactly Pytorch from before that we saw in the training, as well as the inference part. Pandas is like our data frame. It allows for defining a data frame, and this is also something that we had before for dealing with the movie metadata information, where we saying, hey, for this movie ID, what is the movie name? Okay, so that's basically, it's a small table like that. Surprise was again is a library which we are currently just using to deal with a data set, which is that movie lens data set, and time and stuff like that. Okay, so what are these two extra imports? These two extra imports are actually, if you don't have, so if you run this notebook itself, not this notebook, it only has Flask stuff. Okay, so what you need to do is these are just actually just Python files. Okay, we just need to create these files and copy our recommendation model. Okay, so if you go to recommendation models, you just need to copy the training, all these cells into a file called base _base.py and copy the inference part into _inf.py. Okay, so let me actually do that copying and get us set up in a minute. I'm just copying those files instead of copying from the Jupyter notebook. I'm just copying the files that I already have on my local machine. Okay, now I've copied them. Let's go back here. So did anybody try and see whether this URL works? I don't want to close it before other folks try. Let me close this my app.
Yeah, I tried. I was able to access.
Okay. The segmentation model, we don't need it immediately. Okay, save it, it's fine. And what I wanted to do was open those two files that I said we need. Okay, so I just copied them, and how do I mean, why is the case? You can see that two files are there, py and inf. They're just exactly the same. So if I click on inf, for example, it's exactly the same code as that you see in that cell. Um, um, so except for, what's changed is, I'll tell you what's changed. If you look at base, it's exactly the same. The first cell in the notebook is this bunch of imports. Second, cell had some loader, that's the same thing. And then the definition of the model, that's from line 43. And then the main file. Okay, so the main function, that was line 97 here. So that's this base file. The reason why I did it this way is that now for inference, we actually need the whole model class. Okay, and instead of copying this there, we can just import it. Okay, and so for example, from file name import this matrix factorization model, I can just call this instead of like copying that whole class, okay, for inference, for example. Whereas since these two scripts were at the same, so these two scripts are at the same. Sorry, if you look at recommendations, the model definition is right above. When you run, let's say, inference, if you run it in the same notebook, it's not an issue. But if you run it separately as files, you need to import things. Okay, and once you have defined these two files, then the last file that we need is the Flask file itself. So that also, let me just copy, because okay, now I've copied it. So how do I know I copied it? I just added one extra thing. Okay, so you can see this extra Flask _ prediction _ service. So that is exactly the same as that. Let me close these guys, as well as these extra files. So this model serving part has this Flask file. This is exactly the same as Flask prediction service. Okay, so it's exactly the same. But so let me come back to the Flask thing, right? So again, just recall, Flask, all it does is map a URL basically to a function. And in our case, the function is just this. This is the core function. Let's look at the function and then look at if there is anything else to be discussed. So it's just saying, hey, have you sent me the user ID? Okay, so if you go hit my server now, if instead of sending you those random food images, if I turn that off and start this script on, then all you need to send is a UID. If you send an UID, then it'll say, hey, if UID is there in the arguments, then let me store it first, and then I'll try to get, hey, is this guy, this person, this user, have they seen previous movies? If they have, then I'll just save them here. This is not needed actually for prediction. It's just for us, debugging. And I'll also save recommended movies in this extra in this another key called recommended. And then, hey, since I got the recommendations, let me set success to be true. By default, it is false. And then I'll just return that dictionary. Okay, and returning the dictionary because it's a Python object, you need to call an extra helper function called JSONify, which makes it into like basically a text, like an XML text file, basically. It's not XML, it's JSON, but it's the same idea. Okay, and then just run the app. So and now the most of the complexity is in these two extra functions, right? Get previously seen and get top in. But these functions are exactly the ones that are already there in the inference part. Okay, in inference, the offline inference, we already had written this function, get top 10 predictions or get previously seen movies. It was already there, so there's no extra stuff that we did. What extra stuff that we did do is when the app starts, we are already, we have to do some prior work. Okay, when our server starts, the server has to load information, okay, about for example, the model itself, right? So for example, here we are loading the model. You can see it's very similar to the idea. So there's some bunch of numbers that we dumped onto disk, okay, at some point, and we have to load it from the disk. So now you see that we don't have this exact file here. I'm going to copy that again from my local machine. But if we run training, we will get this file, but I don't want to run it again in real time here. So this is the thing which is copying the model. And this is the thing which is giving us some extra information, like, I also need to copy movies .data file so that it has information about, hey, if this is the movie ID, this is the name, and this is the genre. Okay, so that's it. So that's the Flask file, and everything else should work. So let me copy those two files. It's called movies.dat or movie.dat. Movies and recommendation pickle file. Okay, now I have added it because you can see that here. I just added two extra files, which is a movies.data file and a recommendation model file. And where did I get them? If you run the training cell, you'll basically get this file. Now, where did I get the movies.data file? That's also a pretty valid question. That data file you'll get if you download the movie lens 1 million dataset. Okay, so if I go back to so let me actually close all this stuff, distracting things. But if I go back to, recommendation models. So I'm using a helper, helper package and a helper, I guess, class called dataset. It basically what it does is the first time you execute it, see, it says first time, let's focus on main, forget about the helper classes and all that. First time executed, it says load the built-in function movie lens something. Okay, so actually it should be movie lens 1M. So I'll edit it later. But if I have this, so when it downloads this, it'll download into a local folder. And it'll download this data set into a local folder, and the data set will have movies.data file. Okay, so that movies.dat file. So since I don't have surprise lib, so let me install surprise lib during the break on the server, and I'll show you where the file is, movies.dat file. But let's move forward with the prediction service. Okay, so those are two files needed. I already have those two files in the movies.dat and the recommendation file. Now all I need to do is stop the previous Flask app, Control-C. Okay, and by the way, you can also run exactly the way we run Jupyter server. We can run the Flask app inside a screen session so that it always runs, and that's it. And that's a very, I would say, development model server that you would do. Okay, in production, you need to do a little bit more things, but we're not going to talk about that right now. So let me do Python Flask prediction. Okay, we don't have pandas. Actually, you can also install these packages using pip, but I'm, since Conda was the environment manager and we are in the, it's better to keep one manager. You can also use pip, no issues, but oh, it says download. Okay, let's down. So this is exactly what it's saying. Okay, we'll actually see. So yeah, it's downloads into this folder. Okay, so actually the movies.dat file I did not need because it would be in this folder, so I could just reference it in this folder. So now what it's doing is, you'll see a print where it says, hey, model and dataset loaded. Okay, and after that, the server is ready to serve. And then we'll see if it works by testing it on the browser. As I said, we can also test it out using request library. So let's see. Any questions in the meantime about what we're doing? I mean, it's just a lot of laborious work, but I hope you can see how I'm navigating things and getting things in place. It's not the best way, but okay, I think the machine is severely underpowered, so maybe reading the dataset will take a lot of time. Okay, in the meantime, so we'll come back to this in a second. Let me see what else I have to discuss. Okay, I think, I think the only thing left on this part is just to query and see if it produces some recommendations for some users. Okay, so that's fine. So let me close that.
Professor, quick thing. Last time, because it was 1 million was too much, we changed our thing to 100K and we did it, right?
Yes.
So should we do that now, or are we trying to do it with 1 million?
So this time, you could say, so actually let me open another terminal and see whether it is actually causing some performance issues. I mean, I could have seen this in the Jupyter Notebook as well. Yeah, it looks like it is the case. Yeah, last time we changed it. Yeah, I think it's a good point. Yeah, that machine is now hung. Yeah, I think it was a very underpowered machine that I forgot. I mean, my local machine certainly, and many of you folks' local machine is going to be much better. So I can actually demonstrate it very quickly, even locally, right? I have this all the code and everything locally anyway. Okay, so I actually ran it locally. So let me try localhost 500, so 5,000, sorry. So I did not give any movie name, or sorry, movie ID. So of course it will not work. I guess it was UID. I think you should give question mark. UID, let's say 200. And now it actually does the forward, I guess, propagation, through the through the model. So it's a Pytorch model. So you get the UID, and then it tries out for different movie IDs, which ones have the, it gets scores for all of them and then sorts them and gives you the top few. So actually, this is not well formatted, but you can see, actually, let me do it. Is this done? No. Wow. And even this guy's loading. Okay. So yeah, I think I probably overestimated the performance of that local remote machine. But yeah, you can see that the scene key will have these values. I think up to this point, success key has this value true, and UID has this value 200, which is what we passed. And and the recommended key has this other values. Okay, this is what the current model suggests. Okay, and you can beautify this, as I said, very similar to the food random food image. You can actually now search in a database, hey, this movie, what is its, let's say if you have a thumbnail, you can return the thumbnail, and you can actually create a HTML page, for example, right? So that's pretty much it about this. Maybe some users are not present, for which we should probably fail at some point. Oh, for all users, I think it looks like we're predicting the same thing. Yeah, but we can continue to test, and I don't know if user 50 is there, but yeah, it looks like for many of the recommendations are pretty much the same, but at least the scene movies are different, right? Yeah, scene movies are different, but the recommendations seem to be all the same. So we need to see, I mean, we didn't train the model well, I think, last time. So that's one of the tasks to be done, I guess. Train model better. Anyway, any questions about this part before we move on? So let's come back to our original set of tasks. So the last thing is exercises. I will let you guys look at the exercises. It's mostly about, hey, can we do the same with AWS? And in fact, we did it with AWS during the lectures itself. Can we do it with a platform as a service called Heroku? Okay, so Heroku makes it even more easier, and so that to deploy such a Flask app. Okay, Flask app. Actually, we'll look at managed solutions pretty much in the next few minutes. We'll start looking at managed solutions, so maybe Heroku will become more clearer what its value proposition is and how it fits into a model serving task. Okay. So let's take, actually this is a good time to take a break. So let's take a break for 10 minutes from up to 7:35, and then reconnect. And if there are questions, please ask on chat for now, since I will be away from the keyboard, but otherwise certainly ask during the session after we resume. Hey everyone, welcome back. So I tried changing the size. I mean, so it turns out that the model, the 1 million movie lens data set model, it's just too much for that underpowered machine, T1 micro or nano, whichever that we picked for, and the free tier. And so we'll move forward from there. Okay. So in the meantime, I wanted to, before I jump over to serverless technologies and managed solutions and so on, I wanted to just close up with one last demo. Which is also has an issue. Yeah, I wanted to show you another example. It's a different model, basically. That's all there is, basically. So in this model, so this model basically is trying to classify an image. So input is an image. So how do you give an input as an image, right? So there you do a post operation rather than a get operation. So we have been doing get operation, like how we do this get operation. Instead of that, you will have to do a post operation. Okay. So I think somehow Let's go to the Heroku. Somehow their Heroku is also failing. Okay, interesting. So I wanted to show you the demo of how they are, setting up a form where you can upload an image, and then it'll come back with, hey, this image is of a cat, or this is an image of a dog, and so on. Okay. Maybe we'll demo it next time and host ourselves. This was actually obtained from Pytorch's tutorial page. Okay, and let me just link it here on the chat in case somebody wants to have a look at it. So basically this was a page. Okay, it's Pytorch's website. It says, hey, how to deploy Pytorch in Python via something REST API with Flask. Okay, and so you'll see that the Flask code is almost exactly the same as what we did, except instead of movie recommendations, or instead of this food random food image getting part, they just have a PyTorch model which will predict a class of an image. Okay, so let's actually move forward from there. And one final thing, especially folks who are interested in projects may find it useful, is this link. Again, I'm posting it on chat here. So this is a link of public APIs. Okay, so which means that these are services, and this is where I think I believe I got the food API. I guess I don't know what it's called. Control F. Food. Yeah, I think this is where I got this foodish, link to this service being run by somebody, and it just produces random pictures of food. So instead of that, you can try playing around with, hey, can I use something else? Like, for example, there are some servers which need where you need to pass in an extra bit of information from the client before you ask for information or prediction or something. So that's the authentication, and some of them don't. Okay, so for example, Open Food Facts, you don't need to authenticate. You can just ask for different types of information. You can just click on these links to figure out what you can ask. For example, Chuck Norris database has jokes, and you don't have to do any authentication, for example. I mean, it's not even HTTPS. I don't know what exactly it is. So you can explore this page if you want to get some ideas for your projects. I mean, not just for serving it directly like the way I did. I mean, you need to have a model machine learning model in there, but you can use some of this as a way to enhance your project. Okay. Now let's move over. Let's close all these notebooks that are running. Shut down. Okay, and there are 2 terminals running. Let me close this. Yeah, it's 2 terminals running, is it? Nope. I see 1 terminal, which we don't need. Let's exit that. Okay, let's shut down the 2nd terminal, which I don't know where it is, but okay. Okay, let's go back to, now let's go to chapter 2 and start discussing what the outline is going to be. So we're going to look at this notion of serverless technologies. Okay, it's just one example of a managed solution, and that's what we'll get to. So serverless is not the way to deploy models. There are many ways to deploy models, and one of the, I guess, foolproof, simple way, not foolproof, but one of the simpler ways that to deploy models is exactly what we saw today. Okay, so for example, using Flask or some other web server, with some extra bells and whistles, and you can get pretty far. Okay, as long as the number of users that you have is not too many, you can actually get away with what we did. Okay, so we'll look at serverless. What are serverless deployments, and then we'll look at 2 examples. One, and this is where I think if folks have not yet logged into Google Cloud or AWS, you should start creating an account. So first part will be trying to use serverless technology to deploy a simple prediction model, and the second part will be to do the same with using Amazon Web Services. Okay, so in Google Cloud, the serverless, I guess, workflow, it's called Cloud Functions, and in AWS it's called Lambda Functions. Okay, it's just, and Lambda Functions different from the Lambda function that you see in Python language, but these are the names of the actual services: Cloud Functions and Lambda Functions. So let's actually click on that. Yeah. So as I said, we're going to look at cloud functions and Lambda functions, and what's the problem we're solving. And the problem is this: we have to take care of provisioning, right? So to get to where we were with a simple Flask model, even there we under provisioned the resource, and so I couldn't show our model running on the public instance, right? So actually, in the meantime, maybe okay, I'll turn off the. Okay, let's keep it as is. So we had to do a lot of extra things to get a simple Flask web server which could serve a model's predictions. In this case, recommendations for an existing user who has seen some previous movies. Okay, so since there's so much work, like we'll need to have somebody taking care of this, right? And somebody needs to provision for the first time and maybe even maintain such deployed models. And we also have to worry about scale. And this is where I was saying, if you only have 100 users, maybe not simultaneously, but maybe 100 clients, and they occasionally use your model prediction service, then you don't need that much scale. But sometimes you may have a burst of traffic. Maybe your service was featured in a newspaper, not your service, as in the business was featured in in some appropriate marketing channels, and suddenly they got a lot of new customer signups. So you need scale, right? So you will probably not, even if you use a beef server, you may need to do more than you may need to maybe a single server is not enough. Okay, but in many cases single service is enough actually, but sometimes it's not, and when it's not, you may have a bad experience. Your customers or your clients or whoever is using your model prediction service may have bad experience. And you also want to, the third thing that is a key thing is minimize the time to deploy. And we actually took a lot of hours, for example, 6 hours to get to a point where we deployed on a single server. Instead of that, can it be faster? Where I only care about the Flask. Let's say I'm writing a Flask-based model prediction service, and then I can only care about the Flask and the functions that go inside that Python script, and nothing else. About a machine, which conda environment, can I reduce the amount of information that I need to know or deal with for deploying my prediction service. Okay, and how can a single person really do do this right at scale? Like, for example, there are single data scientists or one person in a data science team who will be able to manage and oversee a deployed ML model at scale. Okay, and that's possible because there are extra these other tools that have been developed, especially these managed solutions, including serverless technologies. Okay. So basically and this is just a pitch for, I guess, many of the managed solutions that we'll see for the remaining few weeks. But software basically abstracts away a lot of these computing resources, whether it's compute itself or disk or storage itself or networking or something else. There are many different aspects of computing. So software abstracts these out. Okay. And so that you can just focus on your model, and inefficiencies or issues with your model, like statistical issues or maybe how quickly your model loops through things and so on. So you only focus on your code base, and the software will focus on provisioning servers, deleting and adding more servers if there is more requests for predictions coming up. It also balances if the software will take care of if it's trying to use your model on, let's say, 3 or 4 machines, and one machine is getting only 10 requests and the other machine is getting 1,000 requests. The software itself will, behind the scenes, balance so that the incoming requests are routed to the server which has low number of requests, so that computing is more, so that things are more optimal. Okay, and software can also take care of your code aspects. So it can also snapshot, basically very similar to Git and GitHub. It's snapshot whatever we write. We can the software can also version, hey, which model was deployed on which day. It can keep track of that. And the overall picture. So that was the problem and the solution overall. And managed services are the, I guess, umbrella name for this. And serverless is just one of many such types of managed services that cloud vendors provide. Okay, and it's not just for deploying machine learning models. It can be used for many other things. but not just serverless technologies, but there are technologies which abstract away you trying to maintain or spin up a database server, or you trying to have an authentication system on your app, for example. Many of the things are getting abstracted away, okay, and getting managed by third parties or vendors. So and these are managed as opposed to hosted solutions. And so far we have seen a hosted solution. We literally spun up a machine, installed Conda, installed firewall, things like that, and that's a hosted solution. Okay, and so cloud is basically responsible for abstracting away much of these components, and it makes sense when you're paying a dev a lot of money, like if a business is paying a bunch of developers a lot of money, then they want to efficiently use the time for example, capturing business logic, feature improvements of the products and so on, rather than things that can be potentially are not central to the business and therefore can be spun off, can be other people can be responsible for it. And so what we did in the previous chapter, or basically up till now, was basically a hosted deployment, and we'll try to pretty much not do any hosted deployment from now on, except for play with, let's say, Docker locally to get a feel for it. Okay, so let's come back to serverless technologies. So serverless technologies technology was introduced in 2015-16 by AWS and Google, and and that's what we're going to spend today for the rest of the minutes that we have. Later next week, we'll look at Docker, and then we'll see Docker itself is a piece of software. It itself is not a managed or a hosted solution by itself, but Amazon and other cloud providers, they provide hosted versions of dealing with containers and Docker, for example. And so AWS ECS, Elastic Container Service, is an example of a managed service related to containers. Okay, and we'll see that next week. Okay, and just a caveat about when managed solution is a bad idea. It has its own quirks. So for example, if you don't need to iterate quickly on your machine learning model, or the pipeline at least, you can update the weights of your model or parameters of your model, but if you don't want to touch anything else, then you don't need to have managed solutions, because you have one-time setup cost of setting up, let's say, 10 servers or one server with some way of updating your model, and that's it, right? You also don't need, for example, scale arbitrarily. Like, for example, that you only have like 10 clients, and this is they make 10 requests per hour or something. Then you have a very steady sense of like how much compute you need. So you don't need any scaling aspects. You do need reliability aspects. For example, maybe have an extra server in case one of the server fails or something. And also cost. Okay, because these are managed services, somebody else is gonna charge you for their services. Okay, and so what we'll do today, what we'll do now is we'll look at GCP and AWS in turn, and get acquainted with the serverless technologies. Okay, so let's start with Google Cloud. So serverless technology on GCP or Google Cloud is a Google Cloud platform. It's called Cloud Functions, and basically I guess at the end of the day, what we need to get ourselves started with this Cloud Function solution by Google is just our script, okay, our inference script. Okay, so we just need if we have dumped a model somewhere, we just need to read the model and have a function, which is, for example, what we saw in the Flask prediction service, or even in the inference files. There's a function which says, hey, if you read the model, insert the user or something for which we need to make a prediction. Just that script is needed, and and for example, since we need to read the model from somewhere, we need to read the model from, for example, something that we wrote to disk. Okay, sorry. So it could be, for example, a pickle file or some other format. Okay. Yeah, so let's start with a very basic example. Like basically, without even talking about model deployment, let's just play around with Cloud Functions first, and then insert our model deployment code. Okay, so our model. So let's do that. So let's actually log into Google Cloud. So any questions about where we're heading next? Okay, so we need to go to console. It's at the top right. And then we can just access it by, oh, it's still loading. Okay, we'll just pick Cloud Functions, and by just typing that in the search bar over there. Okay, so now this is basically the interface. Maybe there's extra stuff being loaded, I'm not sure, but basically here we can start. So let's create a function. Okay, so it's actually a UI where it's very easy to choose some default options and get a feel for how Cloud Functions work. So let's say function name, let's call it function1. We will not touch it. Region also will not touch it. Trigger HTTP, and that's because we saw HTTP requests. It's going to be and in fact our trigger is going to be, for example, a GET request or a POST request. We can choose, and allow, and you can see default is required authentication, but let's actually make it unauthenticated. So allow unauthenticated invocations we'll choose, and URL. I mean, we can copy it for now, but I don't know if it's. I mean, we can see it later. So that's it, and then. Okay, and then save, and then next, and that's it. So we are already directly. I mean, so some of you may, if you're doing it for the first time, there will be maybe an intermediate screen which shows cloud build API has to be enabled or something like that. If not, ignore this. So basically, we have now this interface, and this is what we'll play with. Okay, so here you can see there is a runtime choice that you can choose. So here, if you do a drop down, you can see there are different types of software environments. We are interested in one of these guys, okay, Python. And so let's pick Python 3.8. That's only because we had Python 3.8 environment locally. So, okay. So once we pick Python, you can see that there are two files, main.py, it's a Python file, and requirements.txt. Okay, so let's open each one of them. So let's say requirements.txt. You can see there's nothing here. It's actually, so this is, so hash means it's a comment. So it's not really, it's not being parsed. Okay, requirements.txt is a text file that will be parsed by this software, the Google Cloud Platform or Cloud Functions process to install any dependent packages that we need. Okay, so right now there's no dependent packages because this main file is not doing anything. It's a hello world file. It's saying, hey, if somebody else, so it's very similar to Flask. Okay, think of Flask, right? There is a URL, it's mapped into a function. Here it's saying, hey, URL, it will map to this function, hello_world, and hello_world is going to take a request. Okay, this HTTP request basically, and that's it. This definition, this function definition is saying, hey, is the request, get the JSON fields in the request. And if if the argument, if there is an argument and there's a field called message in that argument, then you return basically the message field basically. So you just respond back by saying, hey, whatever is the message field, I'm just going to respond back. Otherwise, if it's a JSON input, so this if else is just to ensure that, hey, if you give me extra JSON input or directly a argument, I can deal with it. Okay, this if else. Else, if nothing is given as, the default thing is at hello world. And in fact, we can just do this and we can drop this if else stuff. That's what this script is doing. Okay. Now, yeah. So we have this. So we just discussed these two files, and so this makes the life very easy, right? You don't care about the Python except for like the Python version here. Requirements, any extra dependencies like pandas or numpy and things like that, you could potentially install it here. There may be some limitation on the amount of extra dependencies you can have, because this is supposed to be lightweight. By the way, serverless technologies, as they're currently implemented by these cloud vendors, they expect lightweight functions to be working here. And then once you have these two types of files, you can just hit deploy. Okay, so let's hit deploy. It'll take a moment to get deployed. Once it gets deployed, we're going to just quickly test it. And this is just to test that, hey, at least the cloud functions work. And then we're going to, all we do is going to change the main.py and the requirements file. Okay. And that's as simple as how to get started with the serving code here. Let's see. It's taking a bit of time. So in the meantime, I want to show a very lightweight model. Okay, so the question here is it the Python script that we need to write in the requirements? So requirements is just going to be, so I was going to show you how you can get requirements document. So for example, here's one very dumb, very not dumb, but there's one way to do it. Where is, okay, let me just open new terminal. Okay, so we are in the base environment. So, we can Okay, so if I do pip, so anyway, nothing is there. So I think we are in some folder, which has some extra files here, but let's not worry about that. So, so let me just make a requirements folder. So there's nothing here. So you can just do pip freeze and then redirect it to requirements.txt. Okay. So if you do this, it didn't print anything. It just gave me my command line back. Now, if I do less of requirements, as in this open and tell me what file content is, it has so many information, so much information. It starts with, hey, this, I don't know what this is, but async generator, back call, certify, click, and then IPython. So there's so many things that have been installed. So Jupyter is equal to version 1. So what this file is basically saying, hey, in the base environment, so many things have been installed. Okay. So the question is, do you need all these installation on the, like for example, scikit-learn, scikit-surprise, all these things have been installed. Requirements document is just a list of, one line per, so it's a document where on each line you just have the name of the Python package and typically the version that you want to use. Okay, so for example, date utils equal to 2.8.1. Okay, or torch vision is equal to 0.8.2. This extra stuff, don't worry about it. That's because of the way this environment is set up. But so that's what it is. Okay, it's not a Python file. It's just a list of packages and their versions. Let's actually get back to where we were. So, okay, this function is deployed, and let's test this function. Okay, so what should I give, right? So it says, if we recall, the function had message. So here I'm going to give a message as a dictionary. It looks like a dictionary, so it's actually going to be what is called a JSON object. Okay, it should be a JSON object is basically like a dictionary. I don't think this is this valid? Nope, it's not a valid JSON. What is valid JSON? Let me just see. Oh, okay. Okay, so what I did was I was supposed to put two, double quotes. So this is a valid JSON. And now if I say, hey, test the function, test is complete. And it's fetching the logs. And you can see the output already. I mean, it's just supposed to, if it was a server, it'll say, it'll respond back by the string, whatever I passed, right? If I don't pass anything, it'll just do hello world. So let me cut this. And, oh, I can't. Okay, let me just do empty JSON and test the function. So it just says hello world, as you can see here. So that's basically how you check that your thing is working, locally. Another way to check it is, of course, to go back to function and actions. Actually, if you click on the function name, it'll give you the URL, and you can actually use many different ways to check this. And this is exactly those three ways that we saw earlier in the lecture. First is you can use locally. Do you have to include that open thing? Okay, so in the testing thing, you saw that the default was actually you are supposed to insert a JSON string here, and that's why I just gave an empty JSON string. Otherwise, you cannot test using this interface, but you can certainly test separately, and that's where I was trying to get to. So let me actually, yeah, you can see the, sorry, I wanted to, nope, I just wanted to get to the name of the function URL. Let's click on this. Maybe it's the same interface. Details. Service account. Hello, all traffic source. No. Okay, I actually have the URL from earlier, so let me just copy that. So let me open it on the server on a separate tab. So you can see, I mean, and in fact, everybody can access it. I just deployed it anyway. So it's world readable. So let me just give it. And there's another question. Do you have to include that bracket? That was just for that interface. Okay, this is just for here. As you can see, if you run this function, so you can't do bracket stuff here. Okay, so when I call this function, I can do slash, I think question mark, what is it called? Message is equal to hi, let's say. So you can see this is a get request. Okay, get requests are generally like variable arguments, like given like this way. What we did with the JSON is, I think it's also get request, but a JSON payload there. Okay. Does it always have to be a JSON object? Oh, it doesn't have to be a JSON object. See here, I just gave some random thing, right? So question doesn't have to be JSON. It can be, and that's where you can see that the code actually helps you do that, right? So it's not something that Google is doing. It's literally what the code is handling here. It says, hey, is there any JSON parts to this request? Get it, okay? And if that JSON part is there, and there's a message in that JSON part, then let's return that message part. Or if there's directly an argument, let's return that argument itself, okay? So this is actually taking care of whether you send it as a JSON or as a GET request, okay? Some terms and conditions haven't updated, okay. So is that clarify what you're asking. Okay, so that's great. We have this. And so now what we can do is not even, I don't know if you can, I wonder if we can just edit this. So let me just change this to, oh, no, it doesn't do that. Yeah, so actually, so I was just trying to see if I can just edit the main file. So what you'll have to do is just go through the two-step process. So what we can do is ignore this function. And now let's create our functions. Okay, so let's create another function. Function 2. Okay, that's fine. Actually, we can call it food or something. But okay, so function 2, again, unauthenticated. And this is just for our demo purposes. Okay, and actually, you should keep generally your model prediction service behind an authentication mechanism. So that is not something that we're covering right now. So let's just save it and do a next. And so again, let's choose Python 3.8. And now let's figure out like which what would be the easiest code to import here. So let's go to our code base. Not this one. That's fine. Yeah, I mean, I just also wanted to show you before I talk about change. So here we can apply the same function. So whatever we had here, function 1. So JSON, you cannot directly pass it easily via the browser. You may, I think, but I don't know how. So we can paste it here. And then you can see, I mean, this is by the way, I'm just showing you an alternate way to, again, test the same function. Okay, the function is already deployed as in the simple function. Again, a get request. But this time we're gonna do a header, no, not header, body. I think, oh no, I think this gets into, So here, if I do message and values something, I think you should be able to just see something. Could not send request. Header is too large. Oh. Interesting.
No, you have an extra E in that message.
Params, right? Where did I change that? Yeah, key, right?
Okay.
Yeah.
Yeah.
No, but I don't think that was the issue.
Yeah, no, that it should have said it didn't find any.
Yeah. That was not the issue. I think it's saying something else, that I am passing something. Query parameters. So I'm just trying to see what's the right way to do it. Maybe it's the header where you pass a message. Okay, so I've not played around with what is called Postman. So
okay.
Okay, that's not the way. Okay, so I think let me not do it in real time, but I just wanted to show you. And actually, for example, I can import requests and requests dot get. Get / question mark message is equal to doesn't matter, and then request is this, and request dot response is just, we can just get text. Let's just print text. So you can see that it just basically echoes back. Okay, so this is I guess a third way. And Postman, I couldn't do it in real time, but you guys know, and basically just give if this is just get request directly. A JSON payload, you can do it on Postman, but I didn't, or using curl, but I don't want to get there. Let me move forward with the let me move forward with the prediction model itself. I think we only have 20 minutes. So we should at least cover GCP with the prediction model. So what I'm going to do next is, instead of, as you saw, the prediction model is actually quite heavyweight. And so what will happen is it is going to be too slow, the prediction functions. If I create a function here, it's going to be too slow. So what I'm going to do is use a slightly different prediction model, which is going to be actually a trivial prediction model, which will not have much dependencies. And you'll see what I'll write now. But it's it's an example prediction model, and then you guys can figure out if you want to change the model to something else, how it will look like. So let me do that. So let's just call it predict. Okay. And the prediction model that I have, I'm wondering if we have it in the Okay, so this is a model which in fact is mixing up a lot of things. So let me explain what's happening here. So it's not, you don't need actually so much stuff. So it's actually fitting a model here. So this line 4 onwards, let me close it. And I'll share this code with you folks. It might have been committed on Git. If not, I'll share it. Okay. So what is happening in this small piece of code? It's just doing simple linear regression. By the way, simple linear regression means just one-dimensional regression. You have a and you'll have an intercept as well. So it's basically regressing y on x. Okay, and there are a bunch of functions, small functions written here. It's basically, this is an example of a code which doesn't rely on, for example, scikit-learn, or doesn't rely on any third party, except for a couple of things. I don't even know if NumPy is used. Control-C. Is it used? Okay, so I need to define that. Okay, that's fine. Yeah, that's fine. So NumPy and math libraries are being used. Math, by definition, will generally be there in the runtime environment. If not, we can add it to requirements. Okay, so what I want to show is that there's a function which can find a model, linear model between x and y. Okay, and the linear model is exactly this. So it's some coefficient times the input plus some offset. Okay, so that's all it is. And in fact, the model, the data that I'm going to give to this model to train this model is a very simple model. It's like, hey, 1, 2, 3, 4, 5, 1, 2, 3, 5. The model is going to be 2.5 times x plus 3. It's a very simple, model. Okay, so which is okay. By the way, this code should not be there in the prediction during inference, but we just, I'm just doing it in a very simple way. So and so this is the data, and I can just call dot fit x, fit the data, and the model will learn the parameters. Okay, just to show you, let me just add it here. Not here. Okay, so this is this is the same function. It's just a fit function which takes the independent variables and the dependent variable and just fits a linear regression model, very simple linear regression model. Okay, and let me execute this. And now if I do model.fit, it will fit the model. And now I have the model object, right? Now if I executed it already, and then if I say, hey, print, tell me what's the prediction for 2. 2 already we know for 2 it should be, what the prediction should be is 2.5 times 2 plus 3. That should be 8, and that's exactly it is. It's very simple line function. And similarly, you can ask for what is it for -1, what is it for 2, what is it for 0? For 0 input, it should be ideally be 3, and it's what it is, 2.9999. Okay, so this is a very simple model. So ideally, cells 2 and 3 should be your training part, like the Pytorch training script that we have. And then once you have that, you need to dump this model file onto disk. Okay. For example, in this case, it's a simple linear model, so you just have to dump B and A, right? 2 numbers to disk. And then the inference, at the inference time, you need to read those 2 numbers and just have a function like this, right? It's a prediction function. Def prediction should just say prediction is equal to whatever you give me times B plus A. Okay. So So I just want to demonstrate with this because it at least looks like a simple machine learning model or a simple statistical model. Okay, so but we need to make a few changes. First of all, there's some imports, so we need to modify the requirements file. And the second thing is this fit should happen. Should happen. So clearly, it's the way we have writing it. Unfortunately, it's going to fit this model every time the function is called. Okay, so every time somebody hits and asks me, hey, give me a prediction for -1, it's going to actually fit the model again and again. Okay, this is a very bad thing. So ideally, I should not have all these lines of code, but only the model parameters, right? And now let me define this function predict, which takes requests as input. I should not have deleted the previous stuff. Let's go to Cloud Functions. Sorry, I just want to see what the function definition is here. Source, whether this is only read-only request. Okay, let me actually copy this. Okay, so we're getting a request. And then if there's a request, instead of returning this, we're going to say, hey, let's return model bracket int of, hopefully we pass the right thing. Instead of message, it should be, input. Let's call it input, or yeah, let's call it input. Input as written, no input found. Okay, so what is it doing? It gets a request. Model object is already there. It's a global object, and it's available for when this function is called. Okay, and yeah, and we should also do the same when we pass a JSON. Although we'll probably not. Yeah, we can test this actually, and that's it. So this is an example, and we are not fully finished yet. What we need to do is also edit the requirements document. So we see that there are two requirements, NumPy and math. So we can just say NumPy. We don't have to really specify it's optional to specify a version number. And math is already going to be there, okay, in Python's, it's code for Python. So let's try how this works. Okay. Okay. Any questions of so far what I did? Before, as it's deploying, let's go back to the source. So you can see all I did was a small helper script which will fit the model in real time. It's a very simple model. It's a one-dimensional regression problem, and there's no noise and all that. I've added nothing. Ideally, you should be just reading the model file from disk. Okay, and so from disk part is what we'll discuss next, right after this. Just seeing that this works. Oh, there's actually an error. Maybe NumPy is too big or something. Or maybe requirements document I didn't specify. Okay, let's see. Actually, let's go back. Okay, sorry. Something incorrect happened here. Okay, it doesn't expand much. Interesting. Viewer. So it may be something to do with requirements, I believe. So error. Oh, okay. Syntax, invalid syntax. I shouldn't have done it in real time. I should have copied. Okay, so we have that anyway. We have a copy of it. So yeah, it's a syntax error I should have checked. Let me redo this and quickly create a function. In the meantime, let me
No,
go back. Yeah.
there is an edit button over there, right? And what does that do?
So that this edit button here. So let me open it. Anyway, function 2 source. So where do you see the edit button?
No, all the way at the top, right next to, yeah. What does it do?
Okay. Maybe we can, yeah, okay. I mean, I guess it's the same thing, but I wanted to keep that function. yeah. So it'll let you redo the whole, I mean, there's only 2 steps, right? So one, you configure, and second you code. I can do that. Let me just create another one because I want to keep, I want to have a reference copy here. That's all.
Okay.
Let me check for syntax. Oh, okay, I forgot to close the second bracket the first time. Oh, okay, it's a very small error. Okay, let me go back and change this. Yeah, what I did was I forgot to close this bracket here. Oh, it doesn't even highlight. This closed, and this closed. Interesting. Okay, requirements NumPy and predict is the name of the function. That should be triggered. Okay. Yeah, now you can see, I think it'll work. Okay, so while it deploys, let me talk about let me talk about storage, right? So we need to read, generally if you're going to use serverless solution, you need to read the model file from disk. And so the way you do it is using, like, for example, if you're on GCP, you will try to use Google Cloud Storage, okay? And so what we can do is, so serverless is only doing the model deployment part. So you will train the model somewhere. Like, for example, we have this server running, right? EC2 server running, where we can, for example, call the training script, right? So from the server, we want to be able to push whatever, let's say, a dumped model. For example, let's say it's a simple dictionary, like value B is something, value A is something. So we want to be able to push that information to the Google Cloud directly from that machine. So for that, what we'll do is, let's go back here. We have this Ubuntu. So I showed you requirements, but we didn't need that actually. Let me go back. So what we can do is install an SDK. Okay, install a command line utility for interacting with Google Cloud. Okay, so this way, so why are we doing this? The objective is, if we install this command line utility, then we can install a Python package. Okay, it's probably called google.storage or something. I don't really recollect the name. So we can install a Python package and again use Python to dump information to Google, like Google storage. Okay, so everything is programmatic. Okay, that's one of the reasons why we are doing this. Otherwise, there's a user interface based way to upload information into Google Cloud Storage, but I don't want to do that. So let me just install this for today, and get it started with. And in the meantime, did that? Which one is it? not this one. Let's close this. Let's also close this. Log viewer, not important. Okay, so now the function is deployed. I mean, that was expected, but let's see in testing. So now we need to give input. Okay, so input, whatever, let's say 0. And we know for 0, it should be 3 is the value. I think, I don't know if it should be a string or a integer, but let's try. Okay, it says, okay, it's internal server error actually. So let's try a different value. Input and 0. Sorry. Nope, I think it is an error. That's great. Secret logs. So this is what this would be a 500 error. Okay, so if you actually okay, Flask. Okay, let's actually let me go back. Not go back, but just open that function. So all I want to show you, and since we have run out of time, is that function 3. Let's say I call this. You know, at least for the last time, if you don't provide input, it's not erroring out. But if I give an input, let's say question mark input is equal to 3, you know, this is actually a 500x error. Okay, so it's like 5xx, which means there's something erroneous on our side. Okay, and we need to fix that. So let's see if I can. Oops. I think several times I asked this. Okay, let's see. Oh, okay. So the return time must be a string, dictionary, tuple, response instance, but it was a float 64. So what the mistake that we made, where is this, is that in the source, this return should not be model itself. Like maybe we should make it a str or something, string. Okay, so that was the error there. So just add a string, like a cast this to a string, this one and this guy, and then it'll work. So I don't want to take more time because I have run out of time. Any last minute questions? Anyway, I'll be here for the remaining time. So for folks who need to leave, thank you so much for joining. Sorry for the several hiccups that we saw today, but these are part of code-based deployment related activities. So okay, thank you. Have a good weekend. And folks who want to stay back and ask questions, you're welcome to stay.